Now I'm going to work with two different applications, ArcMap, our standard 2D application, and ArcScene, one of our 3D applications. I'm going to build a data set. I'm going to build a map with a set of countries that is already pre-classified, and then I want to have a nice little reference layer. Let's move that to the bottom so that we can see our countries and our reference layer. I've got a set of earthquake points for the year 2010. I can bring those in as well. And how many have we got here? We've got, let's do a quick count. Looks like we got 21,000 of these. And you'll notice that I have these also as a couple of different classification schemes already in place. I'm just going to add them in here. You know that not all earthquakes are alike. In fact, let's go in and open up one of these quakes, and what you'll see is they all have the same set of information, a latitude and a longitude that tells it where to go, a magnitude, and a depth. The depth is in kilometers. So with each of these quakes having that much information attached to it, what we can do is to go in and let's take a look at the magnitude. So I'm just going to add this layer in here. I'm going to turn off the generic one. Say go ahead and draw according to magnitude. So here we're looking at quakes 2.0 and above, and as it's drawing you can start seeing some of the patterns that we all know indicate plate tectonics. And for those that are really interested in the way things are looking in North America, let's go zoom in and take a look. And you can see, once again, if we zoom in a little closer, you can see the things that you're familiar with, strong tectonic activity in the California area, but also an interesting collection of quakes happening in the interior. Well, one of the pieces of information that we have is depth. So let's take a look at that one as well. And I'm going to turn off the magnitude, and we've classified the depth according to a color scheme here. Let's jump back out to the world and take a look at this color scheme. And you see a number of quakes that are very shallow, the bright red quakes, and a number of quakes that are deeper. They're in the deep blues. And so we're seeing them happening in particular regions along in here. And those of you that know earth science well should be thinking about this in subduction zones, in particular places around the world. Let's move these down below so that we can see. Let's set up the countries actually to be hollow. Now we can see them a little bit better. Shoot, you know what? What would really help is to see this in 3D. So let's do that. I've now got that very same data displayed in our 3D tool, ArcScene. And you can see the depth from 0 kilometers way down to way deep. And I'm just going to get rid of this legend. And now keep in mind that this is a 3D tool. And what I've done is to send the quakes down into the earth according to the depth that was recorded for them. So we're now able to see these phenomena according to another attribute. And this is a really powerful piece. For those of you that are earth science teachers, you may be looking at this and saying, wow, you can actually take a look in here and see the subduction zone that is occurring. This is a shelf as one plate is diving in underneath the other. The distances have been exaggerated here in order to make this a little bit more visible and apparent for you. But you may remember some earthquakes that happened in Chile last year and in Haiti. Take a look at this earthquake in Haiti. There's a set of earthquakes that happened, and they're all very shallow. Some of the quakes that happened in Chile, there are some deep ones, but there are also some shallow ones in here. So by using the 2D and 3D capacity, we can really take advantage of the power of GIS to show data in the way that makes the most sense and allows us to understand phenomena most easily.